CosmoQuest Astro Office Hours. I am your host, Dr. Matthew Richardson, and first off, before I begin, I want to say that I just loved your stream, Dr. Andres Plazas. That was great. Loved it. Um, but also, um, I want to say hi to everyone else as well. I've been here in the chat for a little bit, seeing the comments, and the very first comment that I came across was Larry saying that he's here to disturb, well, impede my progress with my research. And by all means, I love our conversations. They by no means impede my progress. I love our conversations, guys. 42. That's the answer to everything. Um, so I am back to doing work with my incidence angle analysis code, and one problem that I thought I had solved is not fully solved. And so I'm kind of back trying to figure out what's going on there. But before I jump into that, let me set up a few things. But as I see your names flash across the chat screen, guys, I'll say hi to everyone. Hi, Susie. What's up, Big J? Let's see. Hello, Zeno. Hello, Peter. Hello, Guido. Hello, Skeptici. Welcome, guys. Moo Hoodies, or Hoodles. And Serpent AI. What's up, guys? What's up, Uncle Bill Druin? Welcome to today's stream, guys. Alright, so let's go ahead and set up this problem. So, I think I have everything loaded up. Let's make sure. Got a few scenes here. Nope. Okay. This is a part of me trying to figure out how to solve the problem. But I'm going to go ahead and load up a few more plots here to kind of give you guys a better idea of what's going on. But before doing so, let me go ahead and pop out the chat. Whoa, that's a big jump in numbers there. That's a lot more people than I'm used to. I want to say hi. I'm just going to say hi to everybody who's here. Currently. I'm probably not going to be able to get to all of your names. All right. So, the problem. My incidence angle analysis is one of the many projects the CosmoQuest is currently working on. And the idea is that we have a bunch of images that have been taken by the Lunar Reconnaissance Orbiter that's currently orbiting the moon and taking images of the surface. We have a fairly large set of those images, and we've requested our citizen scientists, that is CosmoQuest citizen scientists, to go ahead and look through our images and identify craters, that is, identify their positions as well as their diameters. And so we have all this data, and what we want to be able to know is, for images that image the same surface area of the moon, but at different incidence angle, that is, the incidence angle being the angle at which solar rays hit the lunar surface, we want to know if this in any way affects our citizen scientists' ability to identify the craters. And so one part of all of this was me being able to create some code that would be able to, well, one, determine if two images overlap one another. And I thought that my analysis code was now properly set up to be able to do that. The only issue is that it does it sometimes and it doesn't do it. Well, it doesn't do it all the time. That's the simplest answer to that. It doesn't do it all the time. So I'm going to give you an example of when it actually is working. And then I'll give an example of when it's close to working. So it's not that it's completely wrong. It's just that doesn't give me the accuracy or the accuracy that I want. So I actually have a few images here. Let's see if I can go ahead and load them up. If I minimize this screen, will I see? Right, perfect. So I'm just going to keep that screen up for now, and I'm going to open up these 3 plots here. So 1, 2, 3. You guys can't see them yet, but you will be able to see them soon enough. And I'm just going to add them to the current screen. So let's do window capture. So let's do this PDF2. And where are you? There we go, overplot. So this is actually an animation, or not an animation, but a graphic that my simulation, my algorithm, let's make sure you can see everything, or one of the many graphics that my algorithm can output. And this, of course, is just me, doing a sanity check to make sure that my algorithm is working the way it should work. So I know things look a little bit stretched here, and that's because I kind of messed up the aspect ratio of the image. But that's cool. The key thing here is to kind of get the point across of what's going on with my algorithm. So let's bring me back. And so basically what we're looking at here in this graphic are the representations of 2 of our images that we've requested our citizen scientists to identify craters within. So really all I'm doing is just showing a box for each image. Where in the case of the yellow box, this is saying that this particular image is larger than the image that's represented by the green box. So of course these aren't real images, but I'm going to show you the real images though for these. And basically we're seeing that the yellow box, which is, let's say image 1, has within it the image of our second image, which is box number 2, or the green box. And so let's go ahead and add the images now. As you've got an idea of what the overlap should kind of look like. Okay, so image 1. And so where are you, image? You're here somewhere. There you go. This should be image 1. Let's kind of minimize. I'm going to try to make sure I maintain. Let's put this here. Let's go ahead and get image 2 in here as well. So I'm just going to shrink this one down too and put it right here. Let's make it a little bit bigger so they're roughly the same size. All right. So for these 2 images, if we go back to our graphic, let's bring that back up top. And this took my face away, but that's cool. Basically what we're seeing here is that the yellow image, which is image 1, should have somewhere within it, roughly on the midsection, the center of the left-hand side, should have image 2 within it. So going back to our images now, so let's go ahead and get rid of this. The basic idea here is that the image on the left should have the image on the right somewhere within it. And of course, initially it's kind of hard to see, but my graphic kind of gives us an idea of where to look. So, let's see if I can bring up these 2 images. Just going to move this one over here, and I'm going to move this one over here. The way in which we can find this is I'm going to do a quick zoom in. And maybe you can kind of start seeing what's going on here. So I'm zooming in into image number 1. We should kind of see something that looks similar. Maybe you guys can see it now. Hopefully you can. But basically, this is showing that my algorithm is able to correctly take 2 images and show exactly how they should overlap one another. That is, if there's any overlap at all. But the problem is that the overlap is good with certain images and it's not good with others. It gets close, but it's not exact like it should be. And I kind of have an idea of what the problem is. And so I'm attempting to resolve the issue. Let me go ahead and quickly check out chat here. So yes, yes, they're oriented the same. Well, not all the images actually. So let me be careful with saying that. And what I mean by that is that the corners of the image aren't such that, let's say for example, the top edge is always going to be the maximum latitude of the image, and the bottom edge is going to be the minimum latitude. I can get images in the case where the top edge corresponds to, and that is if you're looking directly at the image, the top edge may correspond to the minimum latitude, and the bottom edge might correspond to the maximum latitude. And you can have the same situation with longitude as well. Yep. And so yeah, this is a proof that shows that okay, my algorithm can identify the images and match them. And I was thinking that this was always good, and I did find a few other images that worked as well. But then I started running across images where it was finding it was stating that the images overlapped, and it was correct in saying that. That is the algorithm. But the problem was that the representation of the overlap was incorrect. And so let me go ahead and see if I can reproduce those really quickly. Thanks, Susie. Peter, that sounds pretty good there. You guys always talk about food and like this is lunchtime for me, and I'm not getting the chance to really get a chance to eat just yet. My wife actually cooked something earlier this morning. It was great. So maybe if there's some leftovers, I'm going to go ahead and get some more of that for lunch. Okay. So let me go ahead and show you what I mean by my algorithm's kind of like, I can't say the algorithm's being stupid, can I? Because the algorithm is doing exactly what I'm telling it to do. All right, so let's go ahead and reproduce the problem. I'm going to go ahead and switch scenes back to here. And what we're kind of looking at here now in this particular scene is in the top window, that's my Emacs window where I go ahead and edit all my source code. In the bottom window, that is my terminal window where I can go ahead and compile and run my algorithms. All right. This particular part is me trying to figure out the problem or fix it. I'm just going to comment this out. Let's save it. I think everything else should be just fine the way it is. Fine, overlap images, good, good, good. And so this is the part of the code that produces the graphic that I was showing a few seconds ago, where it's showing the overlap between two images that have been deemed to overlap one another. And I found a perfect example of what I mean by it finds two images that do have overlap, but the representation of how they overlap is not fully correct. So let's go ahead and reproduce the problem. So I'm going to go ahead and compile things here now that I've made my change. So make -j. It should compile. It's going to take a little bit longer, guys, because of the fact that I have a lot of different applications open right now. Okay, let's clear the screen and let's rerun it. So I should already have it in memory. And so to run the program, I've named the executable incidence angle analysis, and I pass it one parameter, which is basically a text file that stores all of the incidence angles for each global image that I have. So we have 26 LRO images, and each LRO image corresponds to one global image. All right, so run it. It's gonna output a lot of information to the screen, letting me know exactly how long it takes for certain parts of the program to run. It's going to take longer because of the fact that I have a lot more applications open. I've measured roughly like a factor of 5 times longer for certain things. So when in grad school, I learned that programs need to be able to accomplish 2 things. Well, primarily one thing, but the second thing is I think is just as important at times. Your program should be, of course, it should work the way in which you intend it to work. And 2, if you can get it to run fast, it should be fast as well. I mean, you don't want to wait around a long time. All right, so these are the 2 images that have been deemed to match one another. To break down this image name, for those of you who have not seen one of my previous streams, the first bit of this image before the first underscore corresponds to the actual image name that's been given by LRO. The second character, which is number 1, in between the underscores, corresponds to the I'm going to say the zoom level. And so to kind of break that down, for a given global image, in this case for the global image M138602853LE, we've cut it up in 3 different ways. Each way we've cut the entire image, but we have 3 different ways in which we've cut it. In the first way, we've cut it up in small blocks, smaller images, in which each image has 450 by 450 square pixels. And we've done this for the entire image. The second way we've done it is we've cut up the images such that we still have our blocks, but each block now is 1,350 by 1,350 square pixels. Excuse me, if I didn't say that correctly the first time. And then the third way would be, I think it's 4,050 pixels by 4,050 pixels, square pixels. As of right now, I'm primarily just working with the images that have been cut up using what I'm terming to be the level 0 scaling, which means that it's 450 pixels by 450 pixels per sub image. But in this case, this is I guess a level 1 image. So this corresponds to a particular sub image that has essentially the pixel area of 1,350 pixels by 1,350 pixels, and it's the 360th image that's been cut up like that for this particular global image. So what I'm going to do here, that was a pretty long explanation. What I'm going to do here is I'm going to take this image, and I'm going to determine exactly where I can find it at online. So, I'm seeing that I'm lacking a window that can help me do this. And I don't want to repurpose one of these tabs. So I'm just going to open up another tab, which may require me to actually like modify a few more things. Oh, it didn't. Good. I'm going to go ahead and start up our database where we store all our information at. I have my own personal copy. My copy is fairly old, so I have to like update it at some point. But let's see. So I think MySQL -user root. Good thing about this is that you guys cannot see me typing my password. But it would only be important if you had access to my computer though. So use CosmoQuest. And I'm going to take a quick moment to look at comments because I know I've been talking for quite some time now. Oh man, did I miss the chance to say hi to someone who's at Moo Hoodles? I think I said hi to you earlier, but if not, hi again. Oh man, don't tell people, Mark. I don't want people like, trying to get access to our database. Shh. I think Big J is a little bit closer. All right. So what I'm now going to do is I'm going to open up the table that has the information I'm looking for. And so that table for us is going to be, let's see, select star from, in this case, is the image sets table, which stores all the information for our global images. Where name equals blah, 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 boom. That's the name I'm looking for. Oops, nope, that's incorrect. I don't want image sets, I want images. This stores all the sub-images, and this is a sub-image. And we're going to go ahead and run that, and now it's going to output the information for this particular sub-image. And the key information that I want is this, which is the URL address of this particular sub-image. So this information, that is the images themselves, are publicly available. But of course, you need to know the URLs. All right, so what I'm going to do now, I'm going to switch scenes. Well, let's first make sure that I have it up and running. There we go. I'm going to switch scenes to an internet browser. And we are going to input this. Hopefully it loads the entire image. It should eventually. I'm just going to go ahead and let it go ahead and do its thing. That's not the entire image. There it is. It loaded. Finally. We're going to go back to scene 1. And now we need to retrieve the second image as well. So again, to do this, I need to go back to my terminals. Where was that information? It was here. That was the first image, and now I'm going to go over. I'm going to just go over to the next image, which is this one right here. Oh wait, you can't see it because my face is in the way. Let's just move me up there. All right, so this is the second image. Let's go ahead and do the exact same thing. So go back to the database, and all I have to do is just change the name that I'm looking for, the image name I'm looking for. Run it. Go ahead and copy and paste this into a URL. I remember when I first started doing these streams, I had a difficult time, like jumping back and forth between being able to fade back and forth between the scenes. I'd be working and I'd completely forget that the audience, you guys couldn't see anything, couldn't see what I was working on. So that's no good. But I think I've gotten a little bit better at it. Let's open up a new tab. Let's go ahead and plug this, not there, but here. Plug that in, and it's going to give us the second image. Okay. So these are the two images that we're working with right now. And so I want to also be able to see exactly, well, how is my simulation determining or showing how these two images, are overlapping or related to one another? Well, so I'm going to go back. Let's go back to OBS. Which scene would this be? Let's go back to this scene. This has the information I'm looking for. And so if I go over to my first tab for my terminal, it output a plot. And I don't know if you guys noticed this, but it output a plot. This plot called overlap.ps. So it's stored in this directory. And so this overplot.ps should show exactly how these two images overlap. So what I'm going to do is I'm going to go ahead and open that up, and then I'm going to make a few modifications to the scene that actually has all the plots and stuff. So let's go ahead and navigate. Oh, perfect. It's right here. All right, that looks nice. Oops, I do not want to do that again. So every time, I can't remember what it's called, but it's one of the functions that with Mac and the trackpad where you swipe up and all the screens just kind of like go all over the place. Let me avoid that. So I want this. We're going to switch scenes. We're going to go back here. And I guess I'm going to do the exact same explanation, but for this current scenario, which will require me to slightly get rid of some stuff. So let's get rid of that. Let's get rid of this. And let's leave you for now because I need something to show. Let's actually get rid of this too. What happened? All right, perfect. And then I'm going to get rid of this eventually, but let me actually just change the image. So where are you? You are here. There we go. Okay, so this is supposed to represent exactly how these images overlap one another, where the green area is where the overlap is occurring. Now, the reason why the images are the boxes that are being used to represent each subimage, the reason why they're not square is because of the pixel resolutions along each axis. So within my algorithm, I have it calculate the pixel resolutions, which I think is actually a part of the problem. And I'm going to, of course, end up getting to that eventually, but let's just go ahead and show you what's going on here. So basically, between these two images, they should share a little bit of the area between them. So it's best if I go ahead. I think I might want to actually just go ahead and grab or download those two images that I had here. So let's go ahead and get some copies of those. That way you can better see them together side by side. But before I do that, let's go ahead and figure out exactly which one of these images is the yellow image and which one is the blue image. So image 1 represents the yellow image. So, and that one is the M138 image. Okay. Take a quick break and see what's going on with the chat. Yeah, Peter. Honestly, so basically Peter is bringing up the fact that in the past, I think like at least 2 streams, I had to cancel the streams because of internet connectivity issues. I swear, Peter, I was ready to go postal. If it would have happened a third time, I'm hoping it doesn't. But somewhere in the news, you guys are going to hear about some African American scientist who went crazy on his ISP. We don't want that. I don't want that. Okay. So, right, I want to go ahead and grab these 2 images. Get copies of them. So what I'm going to do is right click. Let's just go ahead and save. Yeah, let's save them. Let's save them to the desktop. But let's give them a specific name. That way I know how to identify them. Desktop. Let's just put this as new image 1. Save. Go to the next one. Okay, I think that's good. And then I can say this is new image 2. Save. All right. So I should no longer need to go back to this screen, but just in case, I'll leave it up or available. All right, so going back here, we can go ahead and we can add the new images. So image 1. And let me just do a really quick check to make sure that image 1 needs to be the M138 image. Okay. So image 1, I think that was the situation. Let's make sure. Yeah, that was image 1. Okay, perfect. Where are you? Oh, right, I don't have you open. So let's go to the desktop. So what I'm doing now is I'm navigating to the desktop using the Finder window, and I'm about to go ahead and open up these images. That way I can quickly load them up using my OBS software. All right. Go back to OBS. You should be open now. Let's redo that. And image 1. I'm going to try to make sure I maintain put that there. And now the second image. Image 2. Let's see what you're doing. Okay, right there. Can slightly make that smaller. Let's see if I can get them to be the same size roughly. All right. Oh, this is actually perfect. So, according to my graphic, image 1, which is the yellow image, should overlap the left edge, or roughly a little bit of the left edge of image 2, which is on the right. So image 1 is on the left, which corresponds to the yellow box. Image 2, which corresponds to the blue box, is on the right. And the idea is that they should kind of share their edges here. So this is the issue, though. So I already know that image 1 is smaller than image 2 according to my graphic. So I'm just going to go ahead and I'm going to zoom in on image 2, and you're going to notice something. Let's go in. Kind of zoom out a little bit. And again, guys, I thought I solved this issue, but apparently I didn't solve it. And it's frustrating, but it's a part of science. All right. So let's see if I can find some identifying features. I'm also going to zoom in on image 1 as well. Get things set up right here. All right. So if I zoom in on image 1, we're going to kind of start to see something. Zoom out a little bit. I'm going to try my best to kind of get them to look similar. Think about here is good enough. Yeah, this is good enough. All right. So if you look, they do overlap. The two images do overlap. Right, perfect. All right, you guys can see. The two images do overlap. But the major issue here is that the location of where the overlap is occurring is not being represented right. And so I'm kind of questioning whether or not I should even worry about this, and I should worry about it, of course. I wouldn't be a good scientist if I wasn't worried about it. I am worried about it, and I'm going to fix it. And like I said earlier, I kind of know where to start, but I'm not too sure if that's going to be the solution to the problem. Let's quickly look at the more pronounced crater on the top left of the right hand pic. Yep. Yeah, they match. I could. I could modify my my algorithm to import these images and then kind of like have them do some sort of overlap. It would just take longer. Yeah, the reason why I've chosen to do it this way is because it's faster. a whole lot faster actually. So to do it that way, Hanny, I would have to again do everything I just did just now, but have the algorithm do it. And so then it becomes an issue of whether or not the internet connection's good and stuff like that, which it should be. But yeah. A border run. Oh man. Yeah. You could have it. Hmm. I'm looking at Zeno's statement here. It's gonna be a lot clearer if you make one image relative to the other. Okay. Yeah, I agree with you. I agree with you. Um, yeah, this was just something I just did really quickly. But yeah, I think that's probably the best way to go about doing it. All right, so now, as with many of my streams, we're gonna solve a problem, and the problem is what I've just put before you, which is kind of figuring out exactly how to get the images actually matched properly. Sorry, guys, I'm just taking a quick moment to think about what Hanny's saying here. You can tell yourself what pixel edges are involved. Actually, I do have that information. Hanny, that's actually, yeah, that's okay. So if I approach this problem in pixel space, oh man, All right, so let me explain exactly how my algorithm works in determining these matches. I'm thinking about what Hanny is saying, and I think I would have to make some changes to my code, but I think it might be best to do it that way. So as of right now, the way in which my algorithm identifies how the images overlap is I've established a coordinate system where basically each pixel would correspond to some length away from my origin, where my origin corresponds to 0 degrees latitude and 0 degrees longitude. But the issue is that the lengths, that is the length from the origin to any given, like I guess, pixel that would correspond to some length away, is heavily dependent upon the pixel resolutions of the image, as well as of course. Long story short, I think what Henny is saying is probably the best way to do this, is to work in pixel space. But nevertheless, even to get to pixel space, I'm leaving out a lot of information here. My mind is going right now, but I know that I'm leaving out information. I'm only given certain information to work with. But maybe it might be best if I kind of like show you guys a few things to make things a little bit clearer here. So going back to my terminal, here we go. And I mean, all the information I'm going to show you here is, of course, it's publicly available. So I'm not showing any sensitive information here. So let's see. Select star from image sets. And let's just go with limit it to one entry. All right, so right now what I'm showing you is one of our LRO images, one of our global images, and all the information we have for it. The thing about it is that for each global image, we know the minimum and maximum and latitude and the minimum and maximum longitude. So as far as being able to determine, and of course each of these values will correspond to one of the edges of the global image. So as far as being able to determine where a global image is relative to my defined origin, which of course my origin is going to be at 0 degrees latitude, 0 degrees longitude, I can determine where the edges, the bounding region of a global image is because I know the latitude and longitude of each edge. So I can make that relationship quite easily. However, to be able to determine where one of the sub-images is located within a global image, and I'm just going to quickly show one of those. I'm going to quickly show one of those. So select star from images, and I'm just going to limit this to one as well. So this is one of the sub images. There is no latitude and longitude information because as far as the sub image is concerned, it knows nothing about my origin. It only has information that will allow it to locate itself within its own global image. So each global image has several sub images, and so the sub image knows how to locate itself within the global image, but has no idea how to locate itself within my coordinate system that I've established. The way in which I do all of this is, of course, I use the latitude and longitude bounding regions of the global image, and I use the pixel information for the sub images along with the pixel resolutions to determine where the sub image is relative to my defined origin. And I know that hopefully that's a little bit clear. But to make it short, one of the corners is I know the latitude and longitude of one of the corners of my global image. I can get a distance from my origin to that corner, and then from that corner, I can navigate down to let's say the corner of one of my sub images. So I can establish two vectors, and to get those two vectors, I need to know the latitude and longitude of the global image, as well as the pixels, the pixel coordinates of the sub image, along with knowing what the pixel resolution is of the global image. And as of right now, I'm working strictly in terms of physical units. But it might be best if I work in terms of pixels. Pixels, that is, convert everything into units of pixels. But again, I think, and this is the reason why I initially thought that the pixel resolution might be the situation. And I did a lot of different things to try to get the pixel resolutions correct. Hey, Noel. Well, Moohoodles, thank you for stopping by, and have a good time. Going to get something to eat there. Yeah, I can easily find the sub images within the global image. Because if you see here for this given sub image, I'm going to go ahead and highlight this information. Actually, right here. So this information gives us the pixel coordinates of the upper left hand corner of this sub image relative to the upper left hand corner of our global image. And then the rest of the information, of course, tells us exactly how many pixels wide and how many pixels high, or the x and y dimensions of the sub image. So yeah, I can really easily locate a sub image within a global image. In fact, I have a graphic that shows that information actually. Yes, Big J has hit it dead on the head. The resolutions for each global image is different. The resolutions change for each global image, and that's what's really making it difficult. And I've done a lot of stuff to try to like get the correct um, pixel resolutions for each image, each global image. It's just that apparently the work that I've done is not good enough because it's still not being able to find overlap between images that come from different global images. So that's what I've kind of been doing lately. And honestly, I thought this problem was solved. And the reason why I thought it was solved was because in the past, I was pulling random images and they were matching. I was like, yay, it's working. I can leave it alone now. But very recently, my boss Pamela, asked, "Hey, can you give us let's step through what your incidence angle analysis, does, and let's go deal with this particular thing." And I went to just grab a random image, and I find out that hey, it's not working, completely as it should work, which was kind of worrisome. So, oh, so how am I IDing the sub images? So I'm not too sure I fully understand your question there. Because each sub image does have an ID associated with it in our database. But I'm not too sure if that's what you're really asking. You know what? Because I never get the chance to say hi to everybody, and I'm seeing there's a quite a few people here actually. So I'm just gonna take a quick moment to say hi to everyone because um yeah, Big J, I'm going to answer that in just a second. So I'm gonna say hi to everyone that I know I haven't said hi to. Um, wow, hi Atomic Zombie, hi Autumn's Rain. Hi, Brutal's Murph. You guys have some good names here. Hi, Carbonaceous. Hi, Denmark. Hi, Eagle Ura. Hi, Efreetium. Hi, Electrical Skateboard. Hi, Faking the Books. Hi, Ferret. Hi, Hiccuping Boots. Hi, Holly Oh, I'm not gonna say the last part of that, but hi Lance, hi Mace Capri, hi Mark Mello, hi Mastermind, hello Missy, hello Mahoodles. Well, you left earlier, but hi to you again. Hello Nico Squid. Hi RP Schwartz. Hello Slow Cool. Hello Tom Ben Scotter. Hello Toxic Pig. Hello 23 Shouts. Hello Untied Shoe. Hello Zorblup. Welcome to today's stream, guys. But each pixel. So yeah, I saw you. Yep, I saw you. You're trying to hide, huh? Um yeah, big J. I agree with you. I should definitely say them in my head first. Um One of those names nearly got me. Let's see. But as far as the pixels are concerned, um, each pixel. Well, no, the only way you can determine the latitude and longitude for each pixel is you'd have to calculate it using the pixel resolutions of the image, along with the fact that the the latitude and longitude bounding regions of the global image. So if you wanted to be able to calculate the latitude and longitude of a pixel within a sub-image, you need that other information. And I'm thinking about all of this, and if I feel like whether I work in pixel space or in physical units, if the numbers aren't right, then it really won't matter. It's just a unit conversion. But working in units of pixels, though, I think would make it a lot easier to be able to identify things. Zeno, that is correct. That is exactly right. Um, Now, if I'm locating images that come from sub images that come from the same global image, my algorithm has absolutely no problem identifying the overlap. It does it correctly. However, I want to say for certain sub images that come from different global images, it can identify the fact that they overlap, but it doesn't identify exactly how they overlap correctly. Like with the example I just showed, it identified two images that have come from different two sub images that come from different global images, and it identified the fact that they overlap, but it didn't show it correctly. The overlap image that I ended up getting was not right. So yeah, exactly what you state there is the problem, Zeno. And I'm thinking the fix to this is the fact that my calculation of the pixel resolutions may be off. Different global images have different resolutions. Um, hey Adam, I missed your name there. Have you been there the entire time? Carbonaceous was trying to, avoid being recognized, and I got him, but I didn't see your name. Honestly, though, for this one, I guess like in graduate school, I got used to just like kind of working to myself. And honestly, the only other person I could really talk to about my issues with my research was my advisor, because I was the only person in our department that was doing what I was doing. So I've kind of got used to working by myself, but I think I'm going to open up this problem definitely to the rest of like the CosmoQuest team and be like, hey guys, help me out with this. Because yeah, to find a solution to it. Because again, I mean, the overall objective, of course, with any research project is to produce a paper from it. And this little problem is prolonging that, that ultimate goal. As well as, of course, present the research to everyone else and show, hey, we did some cool stuff with incidence angle, lunar incidence angles. Huh. All right. Yeah, Uncle Bill Jordan, you are so right about that. Publish or perish. That's a little phrase that I didn't learn until I was like midway into grad school, and then I found out that you have to jump through a bunch of like loopholes. Not loopholes, but you got to jump through a bunch of hoops, you know, to be able to secure, a job somewhere. That is, if you're going to try to like work at. I guess that would be true almost anywhere you go, whether it's to a university or some laboratory. You need to constantly publish things. Oh, that's why I missed you. Yeah, you're so right, Susie. You're so right. All right, so exactly, exactly, Noel. That is definitely their a part of their profession. I couldn't do it. Couldn't do it. I like science. Science without the politics. All right. So I have a theory. the theory, of course, is so yeah. I need a more accurate way to match pixel. Well, not so much to match pixel resolutions, but to get the correct pixel resolutions. Um, because before I started doing my corrections to the pixel resolutions, I had already had everything set up, and the matching of the images was completely off. But the matching has gotten a lot better with the corrections I've made to the pixel resolution. So yeah, I need more accurate pixel resolutions. And so with that in mind, well, let's think about it. The pixel resolution has two units, of course. The top unit can be either some physical unit like some unit of length per unit pixel, or it can be angle per unit pixel. The way in which I'm calculating the lengths is I'm basically just using the arc length. Um, so I know the angular difference between the upper edge and the lower edge of each global image, right? So I can take that angular difference, it's in units of degrees, and I convert that to units of radians, and then I multiply it times the lunar radius to be able to determine what the overall length of the image would be on the lunar surface. And then I divide that by the number of pixels there are along that given axis or direction. So that's how I'm calculating my pixel resolutions. But huh. Yeah, like I said earlier, I'm definitely gonna talk to everyone else on the CosmoQuest team who can help out and see what ideas they have as to why this particular problem is still a problem. Because as far as I'm concerned, I mean, I've done the calculations correctly, but maybe I may have messed something up along the way. Well, guys, the time is now 1:28 p.m. Um, I loved our conversation here, and I apologize that it was more of a work conversation because I wanted to be able to do an article review and share some other cool science that's outside of the research I'm currently doing. Yeah, thanks, guys. Thanks. But hopefully next time I actually can get to that. Actually, I really do want to get to something else. I was talking to Pamela the other day, and article reviews was something that was brought up in our conversation, and I was thinking that hey, it might be great to talk a little bit more about the research I did when I was in grad school, which was on ultra high energy cosmic rays, which is completely different from what I currently do, but I love what I currently do, and I also love what I did then. So thanks, Zeno. Yeah, guys, I love their conversations. Our back and forth, was great. Okay, Peter agrees. So that means that my next stream probably should definitely be, like with an article or something like article review on cosmic rays. So I'll find something and we'll talk about it. Yes, that is the reason why I am ultra high energy. That's what the UHE stands for, cosmic rays. I'm not gonna lie to you guys. I was so happy to know that no one else stole that name. Thanks, Larry. All right, guys. I will see you guys on Friday, 12. Well, I will see you after daily daily space news. I'm not too sure exactly who's going to be doing it, but it doesn't matter because both Andres and Pamela do a great job with daily space news. So I'm looking forward to that, and I'll see you guys after that on this upcoming Friday. So daily space news will be at 12 o'clock p.m. Central Time on Friday, and then I will pop up sometime after. All right, guys. I am now signing off, and I will see you guys on Friday. Goodbye.